Hi guys, I'm gonna do a quick video for you on how to solve a problem with one of the Vox reissue AC30s. And it revolves around get it? Revolves? I revolved the amp. That's hilarious. I've taken the back of this off. What I wanted to say is that it revolves around the problem with these terrible inputs. And you're saying, well, what's so wrong with those inputs? Well, the problem with those inputs is that they're made out of plastic. And so sometimes, oh, what? Wait, what? What? Yeah, they break. So you know the problem that you have when you have an amp that has a chassis like this and it's not horizontal, but it's a vertical chassis, and you know you have your guitar and you got it plugged in like this, right? And the problem is that if you go that way with your guitar cord and this wants to put a lot of torque into these inputs, into these jacks. So what I normally would do was I would wrap my cable around the handle here on the side, and then I would come up and go down in to give it some strain relief. And so if that ever happened, you know, the cable would be pulling against this handle instead of, you know, creating that torque. But even though I did that, I still ended up with this, and it's busted. So what I'm going to do is I'm going to show you how to basically fix this problem by taking this ridiculous PCB board where these plastic jacks are connected, and we're just going to replace this entire board. We're going to eliminate this board altogether. And what we're going to do is we're going to replace both of the inputs with just a standard shunt tip style mono Switchcraft 1/4 inch jack, which is really what should have been used on this amp from the beginning. But in the age of circuit boards and everything else, and in the name of cost savings, they did this. Okay? So it's not super complicated. There's not really a lot going on. So this, let me show you something real quick. If you go and get, if you can find it on the internet, the service manual for the AC30CC2X, which is what this is. This is the CC2 AC30. This particular one's got the blue Alnico speakers in it. All right. And if you get the service manual, you're going to get, wow, look at this, all the schematics. Okay. And if you come to this particular schematic right here, you'll notice that up in this corner, well, what do you got? You got input PCB VX type 1. Well, that's what this is. This is the PCB VX type 1. Okay? So that's your board. And if you take a look at the schematic, you see a few things going on. Okay? So right here, you got your two inputs. Okay? This is your normal channel. This is your top boost channel. And then you've got a couple things coming in here. You've got these little things that are called FB that are in series, and then each one of those little things goes off. They go through a capacitor here, and then those go to ground. And then if you look back over here at your board, you're going, oh, yeah, I've got capacitors here, and then I've got these things right here that say FB3, FB2, FB1. What are those? Well, FB stands for a ferrite bead. And what those basically are, these are just like little noise suppressors. They're basically frequency blockers. So if you have things like electromagnetic interference, or if you have radio frequency interference, these are sort of, they act like low pass filters. It's the same thing that you would see on, I think I have a cable around here somewhere. Here's one. This is a power supply for a device. You ever see one of these little things that's stuck on the end of a cable like that? Well, that's the same thing. Okay, it's basically just taking a cable and you're wrapping it around this ferrite ceramic core, and it basically is to stop interference. So it's the same idea. Vox decided that they wanted to try to put some low-pass filters on the inputs before it actually goes and feeds into the preamp section. Is it necessary? I don't know. Does it help? I don't know. But I suppose that we could continue to have these in line, in series, with each of our 3 main conductors here. All right, you see that there's 3 conductors that go from this PCB board and connect to the main preamp board right there. Those are the backside of the sockets for the 12AX7 preamp tubes. And yeah, so we could leave those if we want to, I suppose. You probably don't have to, but... And then each of these capacitors here goes between, one goes between the tip here and ground, one goes between the tip here and ground, and then the ground here, the shield part of these particular style of jacks, the grounds, of course, are down here, the tips are up here. These are tied together, and those go through one of those capacitors, and then to this middle, the middle wire of that connector right there, the one with the blue stripe on it, that's the ground, and it goes through a capacitor there to ground. So that tip, and the grounds each go through their own 22 picofarad, or picofarad if you prefer, but I think it's really pronounced pico. And they go to ground. And then you're saying, okay, well, what's this connector right here? Well, if we have 2 inputs, then we have 2 tips, and we have got a ground, right? So this would be our normal channel here. That one goes to this outside one. The tip here for our top boost goes to this inside one. I think that's right. And then the ground is on the center. Okay, so that's really all that's coming off of this board and going through this umbilical here, this connector. So you've got a tip, and then in the middle, you've got the ground. So what we're gonna do is we're gonna just ditch this stupid thing. We're gonna clip this off. We might have to extend these wires and make them a little longer. And then we're just gonna put in a couple of these. Nice, robust, time-proven Switchcraft 1/4-inch input jacks to make a much sturdier, much more roadworthy Vox AC30CC2X. That's what we're going to do. And it's pretty simple to do, really. It's not super tough. I can show you how to wire it up, and that's what we're going to show you in the video here. Okay? So follow along. So one other thing about these, the PCB before we continue on, you can't just replace this whole unit any longer. It's been discontinued. I don't think that you're going to find it. I mean, I looked a couple of years ago. I just looked again. I can't find them anywhere on the internet. That's the part number, the 053-321 /00110, whatever. You know, so, you know, if you wanted to, it would be great. If you could just replace this, then it wouldn't be any big deal. But you can't do that any longer. So that's the main reason that we're going to be doing this. Now, you can change these plastic inputs. I think that you can actually get these plastic jacks. But again, you know, you're still going to have to take this out. You're still going to have to take the time to do it. You still have to buy the jack. You know, I think that the Switchcraft is a better way to go. Another problem that some people have with these is they'll over torque the plastic nut and they'll crack the nut so that the nuts will crack. And then it's like, well, that gets ridiculous. So that's another thing that happens with these things. Or you have the problem that I had, like where mine just broke off. So the PCB is just, you know, I think that it's just kind of cheap and you should replace it. So. Okay, we're gonna desolder these little beads here. these little ferrite beads we were talking about earlier. Right? See if we can, they're all along this back up to these three. That's this, and this one. We're gonna just see if we can't desolder those and get those pulled off. So these ferrite beads we were talking about, you know, these sort of take the place in the way that this circuit is done. They sort of take the place of a shielded cable that you would normally have on the inputs of most amplifiers that you would see, like all the old hand-wired style, you know, where you would have your input go directly, you know, through a resistor if it was a high gain or a low gain style input, and then it would go directly into the grid of the first preamp tube. You would just use a shielded wire. But it looks as though this is just sort of an inexpensive way to add some shielding. It's our first bead right here that just fell right out, right there. And let's see, these ones might need a little bit of encouragement. No, just push them through. This is just an inexpensive way to add some shielding at the board. Let's see if we can just get that to come right up through. That one's loose. That one's on. Dogs, I'm going to need you to stop that because we're making a video. There we go. That one is free. Okay. So those were the ferrite beads. Those are the locations for them. We just took them all out, and I've decided, yeah, why not? I'll put them back in. These little unusual thingies. Like I said, normally what would happen, you know, on a standard guitar amp where you have your inputs, you'd have a shielded cable. So you'd have the tip would run on the center conductor, and then of course, you know, you would have that wire mesh that would be basically for the shield part, and that would be the thing that would actually filter out any of the radio frequencies and that type of thing, because that's of course carrying the signal. So from the input, you know, and then basically where it lands on a tag board or wherever, you'd have it going from there through a shielded cable. Now this is such a small run of cable here, of wire, that you're probably not going to pick up much, which is probably why they decided that this was probably enough shielding for that. You know, it's just such a short run of wire that they probably said, well, you're not going to get a lot of, this isn't going to really pick up much. And they're probably right, you know, and so this was just a cheaper way of doing that. But again, I'm gonna, you know, you might say, well, why don't you just use shielded cable and forget about this little umbilical, and you know, you could just directly connect it. Well, again, because it's such a short run of cable, I don't see the point. It'll probably be just fine. And I never really had any problem with this amp. I mean, right? Because that's the proof, right? The proof is in the pudding. You know, how did the amp sound before, you know, you did all this? Were you having all kinds of buzzing and humming and weird stuff that you could attribute to, you know, either magnetic interference or, you know, radio frequency interference or any other, you know, any other kind of thing? No, I never really had that with this amp. So it was never really an issue. So if it worked before, then why change it, right? So again, we're going to be going from these plastic 1/4-inch inputs, and we're going to be putting in the Switchcraft shunt tip type, and we're going to be doing away with this whole thing. I'm not going to reuse the capacitors, so you're not going to see me desolder those. I just have some new ones in the same value, so we're just going to use these ones because they have longer leads. So that's really all we're going to do with that. And then when I'm ready, I'll snip this off at the last minute. But now we're going to get to soldering to our Switchcraft inputs. And how we're going to do that, So the way that these work is this, if you're looking at it like this, right, you've got the 3 lugs. This lug over here, that's the tip, okay? So that's the one that's gonna carry the signal, okay? So this one is the tip. This one here is the little shunt. That's the piece right there that attaches to the tip and doesn't disconnect it from ground until you plug in your 1/4-inch jack, or your 1/4-inch plug, sorry. This is the jack, that's the plug. So you've got the tip, you've got the shunt, and then over here you have the shield, because you can see that that is part of where the shield touches here. Okay, well here we have the 2 jacks, they're wired up. So over here on the first one, we have the bead, okay, and then going from there, this is the lug for the tip, it goes through that capacitor and goes over to shield, okay. Same thing happens over here. This is the one that goes through the bead, comes over to the shield through this capacitor here, and then the 2 bits of the shield that are the shunt tip part, they're tied together and they go through a bead, and then they also share this capacitor back over to the shield. So these 2 middle parts are connected, and we still have the same 1, 2, 3 connections that we had on our PCB board, right? Those 3 right there, okay? So now what we're gonna do is we're gonna disconnect this, this connector here, and we're going to tie those in. Probably gonna have to use a little bit more wire to connect them to their various things. We have to dry fit this in the amp as well. Make sure that there's room for all this, and then once we have that done, then we can install that after we've got our connector and wiring harness connected to it, and then we can plug it in and, you know, see if it works, which would be cool. Okay, so that's what we're gonna do. Okay, so we're gonna see what the dry fit looks like. That's from the top side. We're gonna go underneath, and then you can kind of get an idea of what they look like on the bottom side. And of course, this is the socket right here that they get plugged into. So that just has to go up to there, right? There's more than enough room for everything. So then we just need to get those connections right to there on the board, and then we're done. So let's do that. Okay, so then we're gonna see what we can do with this thing. And I think all we're gonna do is probably just clip it off. We could try and take it off the board, but I think that this one, there are tabs that are on these, the landed ends of those wires, and the tabs prevent that from coming off. So it's like once that's connected, it's meant to stay connected, and it doesn't disconnect like this end does. So since we're probably going to be elongating those wires anyway, and most likely not reusing it, I think we're just going to clip the wires, because they're going to need to be clipped anyway. So that's what we're going to do. So we're just going to clip them. And forever free ourselves from the bane of my existence, which is this. Okay, so that's now nothing. So now we have these 3 wires, and what we need to do, of course, is so when these were on here like this, I should have mentioned that you have to actually mark these before you do this, because you have to know which one goes to which. I suppose you could switch it around if you want to, just so long as you know which one is which. But the one on the outside, okay, that's this wire that has the X's on it. I'm assuming all of these wiring connectors are the same on all the amps. But anyway, the one that has the X's, and then the one that has, then the one that has writing on it, and then the middle one which has the blue stripe, okay, that's the one that's basically like the ground, or in this case, the shield wire. And then each one of these other ones are the tip. Now, The one on the outside here, that one, if you go and you trace, if you trace it, it's this particular one right here. And if you follow that over, that goes over here. This is where the bead was, and it goes to this. It goes to this jack here, and then it goes to that tip. Okay, and so when these are plugged into the amp, right, they go in this way. This is the normal channel, and so then this one over here would be the top boost. So the top boost is going to be the one which is right here, right? That's that wire. The normal is the one that's on the outside, or the normal is the one that has the little stars on it, okay? I should have mentioned that before. I had it memorized, but I forgot that I'm doing this as a video, and you may not know which one's which before you clip it. So you may want to mark it in some way before you clip those off, but that's the way that it works. And obviously, you know, it's not a big deal. Gosh, if you were to, you know, twist those around, you might just be able to switch, you know, your inputs back to front. But it's, you know, you may or may not have room to do that. So anyway, but that's the way that that works. So we're gonna strip these wires back, and we're gonna give ourselves a little bit more, wire. We're gonna extend these a bit, and then we're gonna go ahead and connect those to our jacks, and then we'll test it out. And I'll show you how we'll do that. With these back out of the amp, this is the orientation that they sit in inside the amp. Okay, so this is the top boost. This one's the normal. Okay, so this wire here with the stars on it, that's gonna go to the tip here, and then the middle is gonna go to the middle, and then the other tip is gonna go to the top boost. So that's basically the way that those wires are gonna go, just like that. Like I said, I'm gonna need a little bit more room, so I'm gonna add probably a couple inches worth of wire on here so that we can reach these. And then there we go. Okay, so here we are. We have this thing all hooked up. As you can see, I extended the wires and put some shrink tubing over them, and I got this all rigged up, connected to the factory connector here. So all we have to do is basically connect this up, plug it in, and hope that the amp decides that this is pretty much the same thing as when this was in there. Let's give it a try. And there it is. I've created a little bit of an umbilical for him. Let's plug it in and see if it works. Okay, we're back together. We're turned on. Look at that shiny control panel there. What I did was I noticed that I had some real scratchiness in my master volume. Basically what I ended up doing was pulling the PCB board out of this and cleaning all of the pots. And now they are super slick and glorious, and they don't make any sound, and they are not blocking any of our signal or causing any other issues. Believe me, clean pots make a huge difference in an amp. So before I wanted to do this little demo, I decided that I was going to clean the pots so that you didn't have to hear a bunch of nasty static and raunchy awfulness. I'm looking out for you. This is what you get when you watch one of my videos. Okay, so here we go. So check it out. What are we gonna do? We're gonna plug it into the normal channel. So we're plugged into the normal channel, and we're gonna give it a little normal volume. All right? This is our top boost. close to the amp, so you're getting a little bit of the hum from the pickups, but sounds basically identical to the way that it did before we did any of this nonsense. All right, so now if we flip our switch over here, as you know, which blends the channels, right? Now I can get a little bit of both. So that adds the normal on top of the top boost, which can give you a little bit more clean highs, right? So you can, you know, if you're playing something where you have arpeggiated chords or you're playing some open stuff, you want to be able to hear the ring above the tube breakup, you can add your normal channel. That's what this does when you're in the top boost channel and you point the micro switch towards the normal jack, which of course is the way that it works. So all of the functionality of all of this is basically identical to the way that it was before. But the nice thing is that of course, if you were to just leave your cord plugged in like this, you're not going to destroy your jack, most likely. It would take a lot of torque to destroy one of those jacks. However, I would recommend that even if you make this mod, what I would do still is go ahead and put the strain relief into these, because you know you've got this handle right next to you that's basically there. You may as well use it. So that's what I do generally. And it just makes it so that, you know, if this gets yanked on, right, it's not doing much over here. It's not putting any torque on your jack. And if you have the ability to knock over a 70-pound amp that's at least sitting on the floor, well then, I don't know, man, you're a nutball and you need to stop playing that punk rock music. Actually, I'm kidding. I really want you to play the punk rock music, but just be careful, okay? So that is the fix. If you guys have any other questions, leave them in the comments. I'll try to answer them. And might do a video later on pulling the PCB board and getting to all of your pots so you can clean them. It makes a huge difference. It really does. I don't know if I need to like really whip that dead horse, but dead horse. Clean your pots. It makes a gigantic bit of difference. It's not super easy to get to these in an amp like this. You know, modern amps, they require us to work a little bit to do it. But what's really nice actually is that once you get that board out, you have all of the pots on a single board and you can just clean them all at once. It's not like you go and you find one like on an old amp and you're like, well, I'm not going to go through and try to, you know, I'm just going to clean just the one that's there. You got them all together in a line. You just spray your deoxant and blow them out, or do whatever you're going to do, however you clean your pots, and then you're done. You know, and then, I mean, it takes 5 minutes, literally 5 minutes once you've got the board out of the amp. And you want them to, you know, be nice and smooth and, right? Not have any scratchiness. There's no scratchiness in any of these pots. Play with them any way you want to play with them. There is no scratchiness, right? Get a little bit of hum if you crank them too high, but yeah, sure. It's because my guitar is only like 2 feet away, but yeah, okay? So that's what you want to do. You know, that's what you want to do. All right. Anyway, that's your video.